Okay, this is kind of a classic problem that we have actually already looked at, but maybe we didn't realize it at the time. If I have a point A and I have a point B, where do we find point C so that the journey from A to C plus the journey from C to B is as short as possible? And the way we'd write that, by the way, is that AC, the distance from A to C, plus CB is as small as possible, right? Okay. Well, we all know that the shortest distance between 2 points is a straight line, so C needs to be on a straight line between A and B. Well, now we just have to figure out, where that point is exactly. Oh, by the way, we're also told that it needs to be on this line y equals 3. So we know the y coordinate is 3. All right, so let's take a look. One way we could do this is we could think of this as a vector that travels from 1, 5 to 6, negative 2. Actually, let's write this out as a parametric equation. So let's do it that way. So x equals 1. See, and then 1, 2, 3, 4, 5 plus 5t, and y equals 5 minus, let's see, travels down to negative 2, so 1, 2, 3, 4, 5, 6, 7. 7t, and we're not traveling the full 7, we're just traveling 2, so we're traveling 2/7 of the distance. So x equals 1 plus 5 times 2/7, and y equals 5 minus 7 times 2/7. X equals, see, 1 plus 10/7, which is, oh wait, that's 17/7. So that's a number that's a little bit bigger than 2, and that looks about right. And over here, this is 5 minus 14/7, which is 2. 5 minus 2 is 3, which we expected it to be anyway, but that's just kind of a double check. Okay? So our coordinates of our point here are 17/7, 3. Okay? Now, what if, however, right? So here, when we could just draw the line from A to B and we kind of visualize where C is, right? What about down here? What if we want a point C that's on that line so that AB, or AC, sorry, plus CB is as small as possible. But here's the problem, is that the point has to be down here, so we actually have to go out of our way. Right? We can't just travel on a straight line from A to B with C being in the middle, because C needs to be down here. So there's a trick here. What we're going to do is, if I reflect B across this line here, 1, 2, 3, 1, 2, 3, down here to B prime, now any point on this line will be the same distance from B prime as it is from B. So what I need to do now is just connect A and B prime with a straight line, and C ends up being right here. So the distance from A to C to B will be the same as A to C to B prime, and the distance from A to C to B prime with C being here is the shortest possible because it's a straight line. So now we just have to figure out where point C is. Well, let's see, we'll write out our parametric equations then again. Let's see, 1 plus, let's see, this is the point, 1, 2, 3, 4, 5, 6, negative 2. Oh, that's crazy. I picked the same one. So 1 to 6 is 5. And y, same two parametric equations. 5 minus 7t. And let's see. This time we're 1, 2, 3, 4/7 of the way. So, because our y coordinate is 4/7 of the way between the two y coordinates, so both of them should be. So x equals 1 plus 5 times 4/7, 5 minus 7 times 4/7, 1 plus 27. So that's 27/7, which let's say it's a little bit less than 4. 1, 2, 3, 4. Oh, yeah. Looks like just a pinch less than 4. Y equals 5 minus 28/7. 28/7 is exactly 4. 5 minus 4 is 1. So this is the point. 27/7, comma 1. So if I want to travel from A to C to B prime, C needs to be right here, so it can be right in between A and B on a straight line. But since the distance from C to B prime is the same as the distance from C to B, C is also the point where I travel down to the line and back up and make it as short as possible. If you think about it, if I were to say, put C, say, someplace else, like say over here, okay, now the distance from A to C to B prime is longer than it would be if it were here, which means that the distance from A to C to B is also longer than it would be if it was over there. So any other pick for C will make the distance from A to C to B prime longer, and therefore also make the distance A to C to B also longer. Okay, so the trick is just reflect the point across and then find the distance to the reflected point.